Hey guys, moving on to a new concept today, so we'll get away from solving trig equations. However, you will need your unit circles, so if you don't have them, go find them and get it with you because you're going to need it to be able to do what we're doing today. So we're going to be using what's called the sum and difference formulas to find the value of a trig function that's not on the unit circle. So like if you look at our two examples here, we have the sine of 75 degrees and the cosine of 15 degrees. Those two angles aren't on the unit circle, so we don't know them. It's not like I can say, okay, that's 1/2, because it's not going to be. So we have 6 formulas up top here that you guys are going to use. I will always give them to you so you don't have to memorize them or anything. What you have is you have 2 formulas for cosine, 2 for sine, and 2 for tangent. These 3 over here, these are sum formulas because you see the plus sign, and over here these are different because you see the minus sign. What these letters are here, these are Greek letters. That is alpha and that is beta. So it kind of looks like an A. It's not quite an A, but those are both Greek letters. It's essentially X and Y. But I've told you guys this before. When you get to higher level math, they stop using, say the English numeric or the English alphabet, and they go like Greek letters. Okay, so here's how you do it. We got like 3 examples, and that's it. So this should be a relatively easy lesson. You have the sine of 75 degrees. What you're going to do is you're going to break 75 up to either a sum or a difference of 2 angles that are on your unit circle. So you've got to find any 2 angles you want from the unit circle and have them either add up to be 75 or subtract to be 75. Totally your choice. It's not like one is easier than the other. So since it's sine, you're going to be using either formula 3 or 4, depending on whether it's addition or subtraction. Now I will tell you, if you can keep your angles to angles from quadrant 1, that will always make the problem easiest because everything in quadrant 1 is positive. So you'll never have to worry about whether or not a value is positive or negative. All right, so I'm going to do addition first. So I'm going to change 75 to 45 plus 30. Now, you guys have to show me what you turn it into, and you have to designate them alpha and beta. So the first one will always be alpha, and the second one will always be beta, just like up here in the formulas. And I want you to label them. So alpha, although it may look like an A, it kind of looks more like one of those Jesus fish that's on the back of a car. Kind of goes like that. Beta is just almost like a capital B, but it's got a little extra line going down. So that's alpha and that's beta. All right, now what I need you to do is plug the 45 for alpha and the 30 for beta into the correct formula. So if you look up here, we're doing sine. You chose to do addition. So sine and addition is formula number 3. So this will be formula number 3. So plug the numbers in to the formula, and then, then we'll calculate it. So according to the formula, 3, I'm going to take the sine of alpha, so that's the sine of 45, and I'm going to multiply that by the cosine of beta. So that would be the cosine of 30. Then I'm going to add to that the cosine of alpha, so the cosine of 45, times the sine of beta. So that would be the sine of 30. So that was nothing more than substitution. That was me taking this 45, putting it there, and taking that 30 and putting it there and there for beta. Go to your unit circle if you don't know these values. Find them, substitute them in, and then we're going to clean it up to get the final answer. So here's what we got. The sine of 45 is the square root of 2 over 2 times the cosine of 30. The cosine of 30 is square root of 3 over 2. So you're going to have to multiply those together. We'll do that in a minute. Plus, the cosine of 45 is also square root of 2 over 2. You like 45s because sine and cosine are always the same. Times the sine of 30, which is 1/2. Multiply each fraction. Now, when you multiply radicals, it's just insides times insides and outsides times outsides. Now there is no outside, so it's just inside times inside. So you got the square root of 6 over 2 times 2 is 4, plus that's the square root of 2 over 4. Last thing, add these two fractions together. Now you guys are lucky, and you'll always be lucky, because they'll always have that common denominator. So they both have a common denominator of 4. So your answer is going to be over 4. And now you're going to add these two together. Now, a lot of people try to add them together and tell me that's like square root of 8 or something. You can't add them together. They're different radicals. So since I can't add them together, I just put them together. So that's square root of 6 plus square root of 2. And that is your final answer. And now, if you grab the calculator, you could actually check that. So assuming your calculator is in degree mode, so let me put mine, mine's in degree mode already. If I put the sign of 75 in there, I would have gotten that decimal, 0.9 and some change. If I put this answer in there, assuming you put it in right, so that would be square root of 6, arrow over, plus square root of 2, I'll hit equals here, and then hit divided by 4, you're going to notice you get the same exact answer. So that's just me showing you guys that square root of 6 plus square root of 2 over 4 is that the same as sine of 75, so you know you get the right answer. And there we go. You don't have to do that, but you know, it's just a way for you guys to actually see what exactly is going on. All right, I'm going to go back to the same problem and do it again. Except in this case, I'm just going to give it 2 other angles because I want to show you guys it doesn't matter what angles you choose. You can choose any 2 angles. You can choose addition or you can choose subtraction, and it won't make a difference at all. So I'm going to do subtraction this time. And I'm going to do 135 minus, what's that going to be, 60? Yeah, we'll do 135 minus 60. So now I'm going to be using subtraction. This is alpha. This is beta. Same thing. All right. So plug everything into the formula just like you did before. Now, it's the same problem, so we better get the same exact answer, which we will. All right, so I have the sine of alpha. Sine of 135 times the cosine of beta, 60. Now, this is subtraction. You're using, don't use the addition formula. This is going to be formula number 4 because that's the one that's sine and that's the one that's subtraction. So what else we got here? So it's minus the cosine of alpha times the sine of beta. Sorry, barely fitting it on there. All right, so once we get everything substituted in, and you have to show me this. You cannot skip any steps. I need to see what your alpha and beta are. You have to plug them in. You have to show me the values. You pretty much show me every single thing. There's like one step you can skip, and it's not here. So sine of 135. So now we go into quadrant 2 to 135. Now in quadrant 2, sine is positive. So there it is. Sine, square root of 2 over 2. So square root of 2 over 2 times the cosine of 60. Cosine of 60 is 1/2 minus the cosine of 135. Now, that's in quadrant 2. So anytime you're not in quadrant 1, you're going to have to deal with getting signs correct. So if I'm in quadrant 2, cosine is negative, like it says right there. So make sure you put a negative there. So that is negative square root of 2 over 2. And the sine of 60 is square root of 3 over 2. Okay? Multiply, and then we'll be good to go from there. So this is square root of 2 over 4 minus, this is going to be negative square root of 6 over 4. Now, minus a negative is going to turn into plus, which is good, because we know the answer is a plus anyway. And then we're going to be done. So square root of 2 minus a negative square root of 3 is square root of 2, square root of 6, plus square root of 6